Hi, my name is Yiqing Wang. Today I'm going to introduce the Stoogesort algorithm. The first part is a description of the Stoogesort algorithm, and the second part is about the explanation. The third part is the complexity of the Stoogesort algorithm, and the last part is other aspects. The Stooge sorting algorithm is a recursive sort algorithm. It's slower than bubble sort, so it's not an efficient algorithm. But it uses the overlaps to sort the array, which is interesting. We can see that the principles of the Stoogesort algorithm is very simple. First step is if the last value is less than the first value, then swap them. The second step, when the subset has more than or equal to the 3 elements, sort the first 2 search elements, then sort the next 2 search elements, and finally sort the first 2 search elements again. For the first step, it's easier to understand. If the array size is 2, it can sort the array correctly. Take a look at the second step. Why do we have to call it twice on the first 2 search elements? This is because when we use this sort on the reversed array, we can make sure that the elements should be in the first 2 thirds, but actually those elements are in the last 1/3. They can be flipped to the front. I will specify this in the next slides. Why is this number 2 thirds? In order to make the overlap have enough room for the most extreme elements. So when we do a reversed array between the first call and the second call, the middle third of the overlap is the last third of the sorted elements, and between the second call and the third call, the middle third of the overlap is the first third of all the sorted elements. This is a simple proof of the correctness of the algorithm. We can divide an array into 3 parts. The first part is A, the second part is B, and the third part is C. After the first call, AB is sorted, and the elements in B are larger than A. After the second call, the elements in C are larger than AB. So the elements in C are the largest 1/3 elements of the array. At this point, AB is out of order. So after the last call, AB is sorted again, which explains why the first 2 search elements are called twice, to make sure the ordering of the array. Let's take a look at the space complexity. The space in the runtime stack in recursive calls counts at extra space required in Stoogesort. Each call to Stoogesort triggers 3 recursive calls, but only one of them is executed at a time. The first call ends before the second call begins, and the second call ends before the third call begins. Only one branch of the recursive tree is being exploited at any given time. Each recursive call of a recursive algorithm takes up big O of one space. Stoogesort splits the array into 3 recursive calls. It has a maximum depth of n by 3 when going deep into one branch, so the space complexity is big O of n by 3. Because we always get rid of the constant, so the final space complexity will be big O of n. The time complexity, you can see the equation on this slide. We can use the master theorem to calculate the time complexity is n squared. The time complexity of the Stoogesort does not depend on the input data, because it always checks if the first element is larger than the last element, and it checks every array position if the array size is 3 or larger. The Stoogesort algorithm can help you understand the recursion better. If you like the slow music, you can try listening to the sound of the Stoogesort. This is a link. Works cited page. Thank you.